Right, okay. Let's talk about question number one of AP Physics 1 2024 actual exam. Um, this one says that a block of mass m is released from rest at point A, all right, at a height 6r above the horizontal. After being released, the block slides down the track as shown. When released from point A, the block does not lose the contact with the track at any point, and points B and C are located at the highest points of the respective circular loops of radius r. All the friction forces are negligible. Okay. A diagram A shows an energy bar chart that represents the gravitational potential energy of block Earth system and the kinetic energy of the block at point A. When the block is released, uh, and the kinetic energy of the block at point A when the block is released from rest at height 6r. Okay. Okay. All right. Okay. Uh, so K is just zero. It means that obviously since it is released, there is no kinetic energy and it has a maximum of potential energy because it's at the maximum height. Now draw shaded regions in diagram B that represents the UG and K when the block is at B, which is 2R above the horizontal. Shaded regions should start at the dashed line that represents zero energy, represent energy and energy that is equal to zero with a distinct line on the zero energy line, and the relative the relative height should be okay. Relative height should matter. All right. So what is the initial energy over here? If we talk about what is the energy UG, that is going to be mg times 6r, or it can be written as 6 mgr, right? At this point, what is the potential energy? The potential energy is going to be, obviously the height is going to be 2r, not r, because 2r is a diameter. So that will be mg times 2r. So that is 2 mgr, which is 1/3 of that much. But since the total energy is conserved, we can say that U at A plus K at A should be equal to U at B plus P at B. I'm just conserving the mechanical energy. U at A is 6 mgr, kinetic energy at A is 0. U at B is 2 mgr, and that is K of B. I don't know why I wrote P here. It should be K of B. So this means that 4 mgr is the kinetic energy at B. So what this means is if UA, how UB and KB are related. So this has a value of 6 mgr. This has a value of 2 mgr. So we know that this is 1/3. So obviously this is going to be 2/3, which is 4 mgr. So we have to draw 1/3 and 2/3 height equivalent to 1/3 and 2/3 of UG. So 1, 2, 3, 4, 5, 6. So this has six you know, six, perhaps the small heights are included in that UG. So 1/3 of 6 is just 2. So we will include 2 bars. So that's going to be UG. And kinetic energy, I'm going to include 4. 1, 2, 3, 4. That's going to be the kinetic energy. That's how it should look like. All right. The next question is, starting with conservation of energy, derive an expression for the speed of the block at B. Express your answer in terms of. I think we already kind of did this question, right? Um, uh, in the previous one to derive it, at least we did maybe some part of it. We found a kinetic energy at B, right? So we can just borrow this, and we have started actually from the conservation of energy. So we are conserving the energy. We are saying that mechanical change of mechanical energy is 0. I'm just going to go back and perhaps pull this figure up so that I don't have to go back and forth again and again. So the way I'm going to do this is I'm going to say that the mechanical energy at A should be equal to the mechanical energy at B. Mechanical energy at A is potential at A plus kinetic at A is equal to potential at B plus kinetic energy at B. Potential energy is mg 6 mgr. We already did that. This is 0. This is 2 mgr. We already did that. And the kinetic energy will be half mv square, where v is the velocity at b, which is what we need to find, right? 6 mgr minus 2 mgr is 4 mgr. So 4 mgr is equal to half mvb square. M and M is gone. Multiplying both sides with 2, we have 8gr is equal to vb square, which means that if we swap, then vb square is 8gr. Then vb will be equal to root 8gr, and square root of 8 is 2. So we can write this as 2 times root 2 gr. That will be the expression for the velocity of the block at the point B. All right, so the next one is we have to draw an FBD of the sphere when it reaches point C, considering this dot as the sphere. So obviously there is a there is a gravity force, which is mg pointing downwards. And since on this big loop, this sphere is over here and the sphere is touching uh, uh, the loop, right? So that acts as a surface, and perpendicular to the surface directed outward, there will be a normal reaction. Uh, Comparing the length of the arrows, I'm not sure. So maybe you can make it a little smaller. Maybe they are equal. Actually, that all depends on what is the speed over here. So we do not know. Maybe just make them unequal. I think I don't think so. They are going to grade you based on the relative length, because they are not even saying that, and it's not possible to determine. Okay. The next one is a student claims that 4r is the minimum height of point A. Claims that 4r is the minimum height of a minimum height of the point A, such that the block can slide through point C without losing contact with the track after the block is released from it. Be free explain why this claim is incorrect. So the only way to prove that incorrect is to actually determine that minimum height, right? How will we determine that minimum height? So uh, this concept says that when this is just about to lose the contact, so this is like the limiting case. At that limiting case, Fn will be, we will assume that Fn is just 0, because that's a limiting case. We are finding what is the velocity when it just lost the contact. So the only force which is acting downwards is mg. So what will be mg? And since it is moving in a circular motion, that should be mv square over r. So m and m is gone, so we are left with gr is equal to v square. Okay, let's keep it aside. Now we are interested to find what is this minimum height. So let's say the height is h. So if we conserve the energy, then we'll say that mgh, which is the initial total mechanical energy, should be equal to the total energy which is at point C. And at point C, what is the height? The height is 4r. In fact, now that I see it, I don't really need to do all this. I mean, it's not like we cannot, this will be marked incorrect, obviously. Let me, complete this, this thing, and then I will tell you another way to actually explain it without using the equations. So at C, the energy will be mg times 4r plus half mv square, where v square is gr. So this is gr over here. If you look at this carefully, mg, mg is gone. So we are left with h is equal to 4r plus r over 2, which is just 4.5r. So that's why the claim is incorrect. That's method number 1. Method number 2, which is more intuitive and makes more sense, maybe, that student claims that 4r is the minimum height of the point A, such that the block can slide through C without losing the contact. It doesn't make any sense. Why? Because if you release at 4r, and since it has to again climb by 4r height, don't you think the speed over here will become 0? Because it is being released, the total initial energy is only the potential, which is at 4r. The final energy is also the potential, which is 4r. So obviously it is released and it will come at rest. At C, it will come at rest and it will just instantly drop over there downwards. So it will definitely lose the contact since its velocity just becomes 0. So that's why this claim is also incorrect. So you can explain it either way. You can explain it just the way I did. That is also totally fine. And the other way is, of course, that since it is released from 4R at C after climbing 4R, its speed will become 0, means it will drop and hence lose the contact. All right, that's it. This is all what we have for question number 1. So I'll see you in the next video with another one. Any questions, please post it down in the comment section. Bye-bye.